Okay, I'll share one more time the whiteboard. Okay, you nampak whiteboard sekarang? Okay, good. Alright. Sorry for the trouble. Saya tak tahu tiba-tiba hang tadi. Okay, alright, last one. Anyone would like to share whether it's possible or not? Patterning SL2 without Ilham. Ilham, what do you think? Is it possible to do patterning of SL2 without resist? Naim, photoresist to make a pattern on surface. So Naim, cannot. So you still have to have resist. Turn him. Okay, good. Right. So maksudnya you paham proses ni. Good. You still have to have photoresist on in order to do the patterning of SiO2. Okay, sebab apa? Kita akan go through first kenapa dia tak possible? If let's say this question comes up in test 1, for example, we're gonna talk about test 1. It's gonna be sekarang week 5, right? Week 5, I think. Saya pernah lupa. Week 5. Test 1 is gonna be in the week before the mid-sem break, week 7 then. So to be able to pattern your SiO2, you still have to have your resist on. So you need to have your resist pattern first. Resist. I put R here. Resist. Then only you can do the etching of SiO2 in the exposed area, okay? Then only you can remove this part. Remove. Then only you can remove the resist. Okay. Remove the resist and then remove this part. Then you're going to be left with pattern SiO2. Okay. Pattern SiO2. So you still have to have the resist. Kenapa tak boleh pattern SiO2 directly? What's the main reason? The answer is apa characteristic of the material yang kita perlu pakai? In this case, the resist. What is the characteristic of the resist for the lithography to take place? Apa karakteristik yang paling penting that you've learned all this while? Block light, not quite, but close. Light tu betul lah, cuma block tu tak betul. Apa karakteristik resist yang paling penting to be able to enable lithography process? Light is true, but block is not. So how would you summarize one feature of photoresist to ensure solubility? And well, no, not really. But that's among the main features. But what's the main thing? What's the most important keyword? It has to be, so the resist has to be, or the material has to be photoactive. Photoactive. Apa maksud photoactive? It has to be responding to the light. Okay, dia kena light sensitive, if you like, light sensitive. It has to be a light sensitive compound. Light sensitive compound. Okay, so is SiO2 light sensitive compound? SiO2 bukan light sensitive compound, so therefore it cannot react to the wavelength of exposure during the litho process. And this actually goes back to the why do we use the yellow light as well? Why do we use the yellow light? Why yellow? Okay, if I would like to ask you this, what would be your answer? Kenapa yellow light in lithography? So we've learned about clean room, we've learned about the yellow light in the space of lithography, but why yellow? Anyone? Chingwei, what do you think? Why yellow light? So let's discuss. This is Friday before we go to part 2. Chingwei, what do you think? Kenapa yellow light? Long wavelength? Yes, long wavelength. What's the wavelength of yellow light? Super search. What's the wavelength of the yellow light and write it down there. Peak photons. Nope. It's related to the long wavelength. So why yellow? So yellow is long. So then what is the wavelength of yellow light? Cuba Google search and write down. Okay, about 580. Okay, 580 nano. Okay, so that means kita pakai 580 nano in the litho environment. Okay, I mean in the space, not in the process, in the space yang people working in. Then why yellow? Why 580? So if you have yellow light as your ambient, so what do you plan with that? Kenapa yellow? Can it be visible light? Can we use white light for lithography, for example? What's going to happen if you use white light? So this is another way to reframe the question. Same thing, but the other way of asking the question. Apa akan jadi kalau you tak pakai yellow light? Try to relate that to the illumination source of your scanner system and what is it actually doing. Apa akan jadi if you use visible light? What is in the visible light? What color and wavelength do you have in visible light? Let's do some basic revision. Cuba Google what is the wavelength range of visible light and write down here. Okay, anyone? Tolong write down the wavelength range of the visible light. Right, 380 to 700. Okay, 380 to 700. Okay, I'll write it down here. Visible 380 to 700. So then the question is, what's going to happen if you use visible light for lithography? What do you think will happen? Anyone? Fatima Zara, what do you think? Fazira, what do you think? Fazira? Any idea? So jawapan lah, tak ada idea. So you want to use the yellow light because okay, no idea. You want to use yellow light 580 nano. So in this case, because the wavelength is long enough to avoid potential reaction with the photoresist. Kita nak photoresist to react upon exposure to the correct wavelength only. So if you're talking about a deep UV system, for example, you want the photoresist to react upon exposure to 248 nanometer only. So if you talk about eyeline, you want the resist to react upon exposure to 365 only. So there will be some potential risk of exposing. If you talk about visible light here, katalah you pakai visible light and you run eyeline process in your wafer fab, in your litho fab, the litho process, then eyeline is using 365 and your visible has 380. So 365 and 380 is quite close, right? So you're using, this is your wavelength range, for example, 380 to 700 for your illumination dalam space, and your 360 is only here. It's very close to the atmosphere punya wavelength. So this is your resist punya ni, PR punya wavelength. So there'll be potential risk of exposure on the illumination wavelength dalam atmosphere. So you don't want that to happen. So basically you don't want to have unnecessary reaction to the resist. So that's why we use yellow light. So yellow light is only used for litho area dalam wafer fab. Other areas semua pakai white light. Macam biasa white light yang dalam space yang biasa kita pakai. Tapi litho saja, sebab litho kita pakai photoresist and it is very sensitive to exposure of the light. Okay, so kalau you kerja, when I was in litho last time, you can talk to people working in lithography. They are used to yellow light. So if you spend hours and hours of working in yellow light, bila you keluar tengok lampu putih, you macam different environment, and it looks so different because you are so used to the yellow light environment. Okay, let's go back to the slides. So now you can see the slides. Nampak slide tak? Or did I not share? I shared the slide, right? I don't share it now, did I? Okay, I don't, I think. Okay, sekarang can you see the slides? Okay, good. All right. Okay, how to rework wafer we've discussed yesterday, so you can look at the flow chart in order to do rework. And how do you do that? You can do that by a combination of you can do plasma etch, actually plasma etch, to do the resist stripping. We call it resist stripping. Rework is resist stripping process. Okay, right. So let's look at the part 2. So to enable or to make sure that the litho process is successful, there are a few parameters that we have to look at. The first one is you want to have high resolution. High resolution here doesn't mean you want to have high value of R, but you want to have good features. Good features too is what it means. What is meant by high resolution here? Bukan high R and equals to K lambda over NA. Yeah? So high resolution means good features, good imaging, and not blurry, and so on and so forth. High PR sensitivity, you want to have high sensitivity of the resist so that it will react upon exposure to the correct wavelength of the illumination source. You want to have good precision alignment as well. We've talked about overlay yesterday. So you want to minimize your X, Y, and everything within your overlay budget. So for your information, dalam litho process, when we do, there is one group, we call it processing. So processing is referring to CED. And the second part, the first part is processing, where you do all the process by CED. The second part is called metrology. So let me talk to you. Metrology. So the first part is processing. The second part is called metrology. Metrology is where you do all the measurements required after the process, before the wafers go to the next process, like etching or implant or diffusion. So metrology composed of SEM measurement in order to verify the critical dimension of the printed resist on the wafer. And then it also consists of overlay measurement to make sure that your alignment is accurate and is within spec in comparison to your previous layers. And also the first one is actually visual inspection to make sure that your printed patterns are clean, no residue, no defects, no pattern collapse, and no other problems on the wafer, right? So we do these three measurements, if you like, or characterizations, if you like visual inspection, SEM, and overlay in lithography process. And these three are categorized as a metrology, right? Metrology. So the first one is processing, where you do the CED, and the second part is called metrology, where you do the VI, SEM, or we call it CD-SEM actually. In lithography, CD-SEM, where you measure the CD, critical dimension, SEM. And final one is overlay in order to check the overlay budget. Okay, then precise process parameter control. We have a couple of SPC charts to be monitored. So we have SPC for CD-SEM measurement. We have SPC chart for overlay measurement. We have SPC chart for defects and so on and so forth. And we also have to make sure that wafers produced, the patterns produced by our litho process has low defect density according to the process specification. Okay, so for your information, in wafer fab or in litho to be more specific, there are hundreds of different possible defects that can be formed on the wafers during the processing or during the handling of the wafers, and they are actually categorized by database created by inline monitoring team. Inline monitoring team, we call it ILM. Ada satu department dekat Ziltara, we call it ILM, inline monitoring team. It is actually a department which monitors defect, studies defect, categorizes defects, and they even have rights to shut down your process and your equipment if your defects count exceed the process limit. Okay, the process limit. So it's done by ILM, yeah, inline monitoring team. So these are among the critical required process parameters that you have to monitor in litho process. Okay, to improve resolution, resolution is given by R, or well, in this case called W min, if you like, or the minimum feature size is given by K times lambda over NA. So K is process factor, so it's related to many factors in the process. Lambda is dependent on your wavelength of exposure. Numerical aperture is a function of the lens and the projection optics they use in the scanner. So to be able to reduce your R, your minimum printed feature size capable by your system, so you have to reduce your K, reduce your lambda, and increase your NA to be able to get a lower R. Right, DOF is another important factor that you want to maintain, or depth of focus, and it's given by K times lambda over NA squared. So it's not a big deal, but when we talk about the latest technology nodes, so DOF will become more and more crucial. All right, photoresist processing. So we're going to look into the properties of photoresist here. Sensitivity is the most important one. It's a measure of how much light is required to expose the resist. Typically, we also call this as dose ataupun energy required. Energy required. Okay, so usually the unit is in millijoule per cm squared. It's how much do you need to expose, how much energy do you need to expose, to be more specific, to the resist for the reaction to occur. So bila kita buat exposure process and you have the mask and exposed areas and the block areas, it's not just about having the right illumination wavelength. It's also about the energy that you use to do the exposure process, in which if you use energy less than the minimum required energy to do the exposure, nothing will happen to the photoresist. So kita akan tengok nanti kenapa. So you need to monitor the energy as well, and you need to have your what I call energy specification, the range of energy that is allowed for you to expose the resist. So exceeding that, something will happen. If you have your energy lower than that, nothing will happen, right? So you need to have it just right in order to get the right CD. And I'm going to show you later on how is your energy or your dosage is related to your CD. Second one is called resolution, where the effects of exposure, baking, developing should not degrade the quality of the image. So this is what I informed just now when I am told about the DOF definition just now. So it's the range of the focus that can be tolerated by the process in order to finish that sentence, in order to produce a good quality image or high quality image. So to be able to produce high quality image in the resist, in the final patterns, so it's not only about the function of your scanner parameters. It also depends on your baking process, type of resist, development process, so on and so forth. Even your baking process and cooling process will also affect the quality of the image in the resist eventually. The next property of the resist is categorized under chemical and physical properties. So the resist need to withstand sorry, there's another problem. Can you now hear me? Can see me and hear me now? Okay. Hmm. Okay, let me share and finish a few more slides. Okay, sekarang nampak slide kan? Okay, can you see the slides? Okay, right. Okay, so the resist changes solubility due to exposure to the illumination source. So it's about the wavelength of the illumination system, and it is also about the dosage of the exposure. So the millijoule per cm squared, or dose or dosage, same thing, right? So positive resist will be soluble upon exposure. A negative resist will be hardened upon exposure, just like what you saw on the previous slides. Solvent, it dissolves polymer into liquid to make it liquid. So allow application of thin photoresist layers by spinning. So it forms 75% of the resist before spin coating. So that's why you need the baking step in order to remove or to drive off the solvent after the process. So we have different types of photoresist and solvent depending on the type of resist that you use. So either it's in the I line or in the DUV or in the ARF or in the EUV system. So we also have sensitizers that modifies a photochemical reaction. So it is dependent on exposure time and intensity. We have additive as well in order to reduce reflection in the reaction. So let's look at positive photoresist and negative photoresist for the next few slides. So photo negative resists are usually polyisoprene type. So it becomes hardened upon exposure because it will form cross-linking upon exposure to the correct wavelength and the dosage. So that makes it harden upon exposure because of the cross-linking of the polymer during the exposure process. So the cross-linked polymer has higher chemical etch resistance, so therefore it's not removed during the development process because it possesses a higher etch resistance, so therefore it's harder to be removed. Unexposed part, on the other hand, will be dissolved in the development solution as what we discussed before. Okay, ini sama aja macam yang slide tadi ya. So the exposed part will be hardened due to cross-linking of polymer in the resist. So the disadvantages of the negative resist, the polymer absorb the development solvent as well. So the poor resolution due to PR swelling. So due to the absorption of the development solvent during the development process, it will probably lead to resist swelling. Macam resist dia membengkak, swelling is membengkak. So due to the absorption of the development solvent, so part of the solvent will be actually in the resist after the process. So that's why your hard bake needs to be optimized to be able to ensure that this is not happening. Comparison of photoresist, negative and positive, but this one is very generic. It's not true. For some cases, you have to really see what do you use for your exposure and everything. Okay. So my last slide. This is a positive photoresist. Hold on. The exposed part will be dissolved in the developer solution. So image the same as on the mask as what we want to have. Okay. It's just that the scale is different because of the projection optics. So higher resolution usually commonly used in IC fab, advanced IC fabs. So last time when I was in Sultana, all the resist are positive photoresist. I think now it's still positive photoresist. So I'll just stop here for this class. So we're going to continue with another properties of the resist and a little bit of imaging and some problems around imaging in the next lecture next week. Okay. Right. So any questions so far? Ada soalan on the latest content? So yeah, before I forget, maybe we'll just discuss on the test one. Sekarang week number 5 kan, betul? I think it's week 5, right? Yeah, okay. So today's what? 13. So we're gonna have our test in week 7. Test 1 will be in week 7. So assignment 1 due next week. Next week Friday kan? 20th I think. 20th 5 p.m. And the other week, week 7, before the mid-sem break, we're gonna have a test, our first test. So it's gonna be on, hold on, yeah, Monday. We have class on Monday, right? Monday, we have Tuesday. Oh, okay. So we're gonna do our test 1 on Tuesday, week 7. Okay. So it's gonna be on 24th of November. Okay, take note, nanti saya akan buat announcement dalam e-learn, tapi I just inform you first. So I'm planning on 24th, Tuesday. So let me just block the calendar. So it's gonna be okay, macam mana eh? So it's gonna be open book test, just like ZAT386. You're gonna be given 24 hours as well. So the questions will be essay based and maybe a bit of calculations. Okay, and the length and the level will be similar to what you have done in ZAT386 test 1 and test 2. Okay, nanti saya akan announce other details about the test, tapi roughly it'll be something like that. So it will cover from day 1 until lithography process. Okay, from day 1 of our lecture, from the introduction until the end of lithography process, and we're gonna finish our lithography process sometime next week. And it's open book anyway, so you can search online and open book. And okay, any intro questions on test 1? So I think you can gauge more or less because you have done tests 1 and 2 on ZAT 387 last time, 386 last time. So yeah, more or less like that for our test 1 this time. Okay, ada soalan lain before we finish? So far so good. Can you follow? Is lithography difficult? What do you think? Is it difficult process? Senang eh? Semua senyap eh? Senyap maksudnya senang eh? Difficult compared to the others. Okay, yeah. Lithography and etching is the hardest one. Well, I would say they are the most complicated processes. And dalam fab pun, kalau aku kerja dalam fab, litho and etch are the most busiest department sebab banyak isu banyak process issue, banyak equipment issue, sebab apa, too many things to handle. And I've got a friend who's been working in lithography for like 15 years dan still tak faham banyak benda lagi dalam lithography process in the fab. So 15 years of experience and still have no ideas on certain issues and problems. Okay, soalan assignment 1 number 2, thermal dioxide characteristic macam thermal dioxide. Thermal dioxide characteristic sama macam thermal dioxide. What's the exact question? I forgot already. It's on the what? The characteristic of the process. Saya pernah lupa saya punya soalan. Thermal oxidation properties. Oh, the process properties, yeah, or the oxide properties, or both, right? Characteristic of the oxidation and the oxide, right? Ada ayat oxide kan? Yeah. Okay. If it's asking for both, then you have to explain the process and explain the oxide. Okay. Sebab saya rasa saya letak oxidation and oxide. So maksudnya thermal oxidation, what is it like? What are the features? And then the oxide itself, what are the features of the oxide formed after the thermal oxidation process? Okay? Ada soalan lain? No more? Okay then, tak ada kot So if there's no other question, then that's it for today. I'll see you inshallah next week, Monday. Bye bye, take care, stay safe. Have a great weekend.